So, last talk of the day. Thanks for being here. Now the weather is good. And I want to talk about team topologies for organization and software evolution, all right? My name is Joao. I'm Portuguese. I live here in Netherlands, and before that I live in Ireland, so it's almost 13 years living abroad. We like it. And yeah, I'm a management consultant on my own company. We can all have feelings with management consultants, but we will get there. And I pretty much help companies to deploy their strategies. But I'm a software engineer at heart. I'm also a team topologies value practitioner, working with community to keep evolving the practices. I want this to be a talk between you and I. And I want to know, how many times did you try to improve a distributed system, but you feel that you are fighting an invisible force? Raise your hand. Couple of you, right? Because, and previous speakers talk about this, just focusing on technical bits is not enough, all right? Most of the times we just think about our deployable services, our infrastructure, but there are other forces playing with that. And what I'm gonna talk today, it's my personal journey. I'm a management consultant, but I'm for train and trade. I'm a software engineer at heart. Started before the cloud. My first job was building systems for courts. Yeah, we need to build it, talk with judges and lawyers and clerks, order hardware, install it, ship it, everything. And across my career, I had different roles as an architect, all of that type of stuff, until 7 years ago, I started to do consultancy, and I start to help companies on their transformations. And I found my passion, because a little secret between us, I just get bored of just doing code. So I was always jumping between being a manager or doing pre-sales as an architect or being a developer until I really found my passion. And today I'm going to talk more about that and how we can use techniques like team topologies to really think about the evolution of the software, the organization, everything as a single system. Another question to you. Do you want a system to be reliable, robust, or adaptable? Yes, all of them, right? Which is true. And I bring the consultant here, it depends, right? Because it depends on type of system that we are talking about. So let's go with these three concepts to go a little bit with more theory and then see some field stories. What are you seeing here, apart from C#? No. So this is a very simple code snippet, but what we see here, it's what I usually on my chaos engineering training tell people that is a reliable API. Because yes, we want to find all the flights between two airports for a given date. But what you can observe here is that here, if the call to the data access layer takes more than 500 milliseconds, I bail out. So any consumer of my API knows that I have these thresholds, although they don't have the business answer that they get something. They don't get stalled forever. So this is one of the characteristics that we can put, and reliability can be well applied to systems like this, right? There are different forms to implement it, whatever, but we can start seeing these playing a role. Next one, what do you see here? A distributed system, a fairly easy distributed system for today's standards, right? Where we see some clients and load balancers and APIs, gateways, and different services. And the thing is that when we enter here, we want our system to be robust. Someone before was talking about blast radius. We have different techniques, right? Chaos engineering grew inside of Netflix. The folks came to study with the safety 2 people on Swedish university that study these critical systems. And we apply these lessons and we can make these robust, which is a characteristic that we can apply to our architectures. But this is not enough. What do you see here? People, teams. One of the things that I'm very happy today, listening to all the talks, is the emphasis on teams as unit of delivery. And I was, yes, this is going somewhere. But what you are seeing here is the typical project organization. 50 people to orchestrate the work of 5 people. But lots of handovers, right? It's what the DevOps community talks a lot. It's what the SRE talks about. It's what the Agile community talks about. Do you think that an organization like this is adaptable? No, because anything that happens, a war, price is going to take this down. If someone is sick, oh, Joao went on vacations and he's doing the release. We cannot release stuff. We cannot compete. And we know that, and that's why this community exists. How can we increase the reliability of the systems? Therefore, companies can thrive. So all of these three things are important characteristics, but we are talking about slightly different systems, or not. Pop quiz question for you. What is a social technical system? Do you know what it is? All right. Interconnected systems. Which systems? We are getting there. So one of the things that I started doing in last years is that I was not happy with technology, because I had the feeling that we are reinventing the wheel. Thanks for the safe one. So I started to study social sciences, because I was like, we have social scientists that are studying how groups of humans interact. They might have some answers. And I found these answers. So that this was formalized after Second World War with 3 branches in Tavistock Institute in the UK. And I'm being studying more and more how different organizations set up. Interestingly enough, the social scientists, some of them from the original group are still alive, never studied technology. And when we explain technology to them, they just tell the industry is broken, which is very interesting. But we can define a social technical system like this. We have social part and technical part. We have our structure of the organization. We have people, right? The cognitive side, how we organize our social events. We had someone this afternoon talk about our reliabilities with our teams, but also we have our technical system, facilities, right? Katawiki has these buildings, our laptops, our IDEs, but also the task, the work that we are going to do. Some of you work in platforms, so it's providing services to other teams, other just to end user type of work. And if we look to software industry, the output of a social technical system is to produce software. Sometimes we consume software that we produce, eat your own dog food. Sometimes we don't, and it is okay. What we cannot forget is that there is an environment around us. And what does that mean? Imagine that I'm a bank here in Netherlands. So as a company, I choose to be a bank. I choose not to be an insurance company, which means that I'm bounded to some regulations. And I choose to be in Netherlands. I didn't choose to be in Italy. Therefore, the way that people interact with banking services here, it's different, right? At the same time, this environment is turbulent and unpredictable, right? We don't know what competitors are going to do. We have lots of fintechs, and we can apply these all in all. So all of these systems have this environment around, and we need to take care about that, including in the environment, the users, right? We saw the needs of the users changing. One interesting example is that General Motors didn't accounted for Toyota going into US market with Toyota Prius, right? They keep doing those gigantic cars. They went bankrupt, right? Because people want those small cars in cities. So the user needs also change. Today you want something that you didn't want 10 years ago. So all of these plays a role. And that's why when I talk about system, I talk about social technical system. And we need to be very careful, because we cannot just optimize one way without optimizing the other one. That's why my initial question in the talk, when we were trying to work with improve a distributed system, you feel an invisible force. You might be fighting here. I also was involved on transformations with organizations that they went, nice, we're going to just change all the teams. And they totally ignoring the systems, right? You talk about Conway's Law, this happened. That's why we need to think about this jointly optimization. And I think that this is at the core of the DevOps community, of course. And someone talked about how DevOps was hijacked by tools and the DevOps spirit was lost. But this is what social scientists already described before we were born. I don't think that anyone here was born after Second World War. but just in case. All right? Still with me? All right. I always like to bring my friend Rob with me. And he says this, a team is a unit of delivery. They start together and they finish together. I could throw this slide away because everyone was talking about that. And this is very important, right? When we cannot rely on individuals, individuals are important. Everyone is unique, but the team is what brings redundancy to a company. Which leads us to team topologies. Who here read Team Topologies book? Who here read the 3 parts of Team Topologies book? All right. It's okay. The 3rd part for me is the most important one that talks about the evolution and team interactions. But Team Topologies came out, the 1st edition came out on 2019. Both Matthew and Manuel are DevOps practitioners, right? Involved with InfoQ community and all of that good stuff. And in the original book, they define 7 patterns, 4 for teams, 3 for teams interactions. And the second thing, and why this book is going up in the IT industry, is that it's useful for contexts where fast flow of value is necessary. Of course, if we are doing software, it's to solve complex problems and we want to get to value fast. But the most important one, and was already discussed here several times, takes a humane approach to design the team interactions based on cognitive load. Because our brain is amazing, but our brain gets very tired very fast. And if you remember, and I can look at you, so you are experienced people, before we talk a lot about feature and component teams, everything very focused on the technical side. We didn't took our human side. Companies that were very successful already felt this and did this, because even before Team Topologies, there were already companies taking consideration the human side. What Matthew and Manuel did was putting names to these, and lots of people went, oh, okay, now this stuff has a name. And this is based on the work of this man, John Sweller. We also talk about cognitive load, and this is the important bit here. Our working memory is only able to hold a small amount of information at any given time, and that instructional method should avoid overload in order to maximize learning. So we study people learning. Now, interesting stuff. You also brought domain-driven design. What do we do most of our time? We learn about domain, right? We need to be comfortable with tools that we use, right? But after we are comfortable with tools that we use, we are learning, or we should be learning, about the problems of our users, which leads to this type of classification. Cognitive load can be broken down in intrinsic, extraneous, or germane. But this classification, and I'm going to show you examples, depends on the point of view. So intrinsic can be, how do Java classes work? Anyone drives a car? Do you remember when you start driving a car? You were very aware where the knobs are. I changed my car last December. The cruise control now is on the other side of the steering wheel, so it was a bit messy, right? This goes with the experience, right? And that's why it's important, the learnings, katas, get used to your keyboard shortcuts with your IDE to get how to use a knife. Extraneous is, how do I deploy to Azure? If I'm a developer, I'm not doing platforms, some things are a bit complex. It's using Kubernetes, how do we set up SSL certificates, all of that type of stuff. And germane, it's my domain knowledge, right? How do instant payments work? Because the instant payment regulation is changing this year. I really need to implement this on my software. So we are always balancing these, and this is where this type of conversation with team topology starts, because if we think about value, we have these 4 team types. The stream-aligned teams, someone talked about this today, that are these long-lived teams that design, build, and run stuff, and own these one or multiple capabilities. And the other types of teams try to support them. Enabling teams, they don't own services, but they upskill and train others. Complicated subsystem teams, very quickly, they pretty much break the value stream. So before the AI, if we want to have machine learning, we go and we hire people with PhDs, because those problems were really hard to solve 7 years ago. Could be an example. and our platforms, right? These abstractions that originally in the first edition, it's called platform team, but now on second edition, we are changing to platform grouping. And then what is also important to realize, and this is the last bit of theory before getting to real life examples, is the three interaction modes. And here is where things are important. First of all, collaboration. And collaboration here doesn't mean the typical thing that it means in IT. So collaboration is expensive. You talk about the communication bandwidth. If two teams are always collaborating, means that we have the wrong boundaries because something is not wrong, is not right. So collaboration should be short-lived. We should get together, collaborate and say, I know how we can break the monolith. We break here, team A goes to the left and team B goes to the right, and we have a service which evolves to this X as a service. We agree on an interface. We agree on our SLOs. We agree how you access to these services. We don't need to talk. You can read documentation. And last one, facilitation. Pairs very well with enabling teams, but also can be lunch talks, can be between stream-aligned teams. Let's say that I introduce a new logging library and another team comes with me and we just pair to see how this works, right? So does it mean more than that? Which these take us with the basics now to start talking about these field stories where we can see how organizations can evolve and software can evolve based on these ideas of cognitive load and team topologies. So who is here old enough to work before GDPR? Do you remember the GDPR times? What did you do before GDPR? Nothing. And then the date came and everyone ran around, right? We always do that. I still remember going to college and semester after semester say, I'm going to start doing my projects earlier. Never did that. Apparently the working place is the same stuff. Sorry, not sorry. So this is a simplified example of a retail company. You are a retail company, you need to do restocking, you have your e-commerce platform, you have your warehouses, so you have storefront teams, you have finance and accounting, and you have product restocking, right? Easy. Someone shouts GDPR, we don't do anything, but the date comes. So we assemble a couple of developers, lawyers, customer service to this complicated subsystem team, and we start to collaborate to see where are we impacted. Luckily, my team wasn't impacted because back then I was leading the product restocking team. We don't handle customer information. It's stocks and suppliers and stuff like that. Cool, we are off the hook, which means that the collaboration continues with the other ones because there is stuff here involved. In the end, the things evolve, which means that these organizations create two platforms. One to handle customer account platform that is reused by the finance and storefront team, but they also as well, we feel that things are changing. We might need a compliance and regulation platform. GDPR might not be the first thing. And what we see here is that even the architecture changed. We adopt CQRS, Command Query Responsibility Segregation, with event sourcing, and we start applying patterns like forgettable payloads. We didn't attach customer information to the orders because if the customer wants to be forgotten, I can delete the customer, but I still have the order that has implication with finance and general ledger and taxes, right? So I don't know your address, but I know that number put an order and I pay my taxes to the Dutch government. So this is one of the examples that if we take the teams, we can start playing around with options, how things can evolve, what things can go to platforms, when we need these complicated subsystem teams because we don't understand the subject, right? Let's be honest, no one really understood GDPR implications until they were enforced. Another one, anyone works with financial institutions or work in the past? I work with central banks and tax authorities. Cool stuff like ECB asking what they could do with cloud 12 years ago. There are a bunch of regulations. They know what we are doing with the money, because I imagine that no one of us have multiple houses and yachts, so we belong to a different category of people. So our money is tracked. Even today, I already closed my bank accounts in Ireland, and Dutch tax authorities know that from year A to year B, I had bank accounts there. It's due to this regulation. A couple of years ago, people thought about we can do money in a different way. Crypto came out, or this way. Sorry, not sorry. But actually what happened inside of central banks is that they create these specialists to see how these affect tax regulations and all of types of things. What was observed there is also that maybe this crypto is a stream. You can see this reflected if you are today in Netherlands, at least the tax system that I know, that they ask how many cryptocurrency you have to tax you, and I imagine that is across the world. So behind the scenes, they are doing this type of things. Their software, the way that they collect information, the way that they regulate keeps evolving, which is good because there was lots of Ponzi schemes. It's not a problem of crypto. Madoff was not dealing with crypto and doing Ponzi schemes. It's a human problem. What I want to show you here is that if we take this team perspective, we're going to find more insights than just only our technical bits. I'm not advocating that we throw things away with our technical bits. What I'm saying is that it can help to do the famous reverse Cornway's maneuver, to start talking about what are the services that our teams provide, what are our user needs, how is the environment around us. This takes years, right? This is not, okay, we have new design of teams, good luck. This is this continuous process. Every time that you plot your teams, it's a snapshot in time. It's like your architecture with your microservices is good today, tomorrow is not like that because a microservice doesn't exist. Two new exists. Team topologies exists beyond the org chart. It's focused on the flow of value, right? It's not to replace the org chart as a place, but this is for us to see beyond that. Why do we exist? How do we deliver value? It's the tree to deliver value between 20 teams or 2 teams. Can we change things around? Should we stop do things, right? We did some software in-house, but perhaps there is now a SaaS solution that does 20%, 80%. Maybe we can use that SaaS solution, right? So help us also to augment our decision information for decision making. And this is the important one, at least for me, but I'm a bit off. I told you, study social sciences. We need to maintain the congruence with the environment while having internal coherence between the teams. What does this mean? The environment around us change. The user needs today are different. 99.99 because everyone expects Google, right? Everyone expects the beauty of an Apple device. So the user needs, the ideals change. Today also people care about sustainability. I must say the last customer contract that I had actually had a sustainability clause. So we went from talking about sustainability to have clauses in contracts between different parties. This is what congruence is. We need to change our internal shape because the environment around us is changing, and also we are changing the environment. If we think about the cloud came out that enable an array of businesses that we didn't thought that was possible. Uber, lots of platforms like KataWiki and Vinted and whatever were way easier to pop up, and this changed the way that we interact with those. And this gets to the final part of my journey, right? We went to the forest together. You went with me. Thanks. Social sciences, this and that. I hope that you didn't get lost, but we got to this beautiful view, right? What I do believe that we need to keep striving in the future. We need to keep striving with technology innovation, but we also need to start thinking how we reshape our organizations. We really need to start to think that an organization is a mesh of platforms and products. Products that our people that pay money for that consume, and platforms that keep changing to allow people to compose these products. And when I'm talking about the platform here, is not just the platform around the cloud or the platform around these, is really thinking about these business functions, right? If you are a bank, you have your payments platform that allow a huge array of other services on top of that to play with it. I think that we need to keep evolving our architectures and our practices to have a mesh of these organizations. And the lenses of flow will help us with this. Techniques like domain-driven design, worldly mapping, whatever, really help us to reason beyond this org chart. We arrive to the end. My name is Joao. You can follow me on social media, and I think that now we have the floor for questions.